Folks, welcome back. Today I want to take a look at another paper from the very recently concluded OOPSLA conference. And this paper tries to automate the postmodern programming process we all follow, which is that we go Google an answer or try to find code snippets from Stack Overflow. The basic premise is that programmers very often write code that is similar to code that already has been written. And it would be nice to have a tool that can go look at existing code and then try and recommend code similar to what you're trying to write. As a very simple example, consider this code snippet which tries to decode a bitmap using Android's APIs. If you start with this simple code snippet, there are still going to be a lot of questions on your mind, such as how to configure it to use less memory, or even how to idiomatically use it and handle errors. And these are the kinds of things that will already probably be covered in an existing code base somewhere. And you need a tool that goes and finds all these usages and recommends them to you. And that is exactly what Aroma, the tool in this paper, tries to do. Aroma takes a code snippet as its input query, and then it returns a set of recommended code snippets. And the properties of the result are that these recommended code snippets approximately contain your input snippet. So not exactly, but it tries to figure out the patterns that you're looking for. And these code snippets are themselves approximately contained in the code body which you were searching. In the interest of making its search results useful and comprehensible, Aroma also tries to present search results that are different from each other so that you don't just get a bunch of search results that are similar to each other. In this sense, Aroma is different from some of the existing tools for code recommendation because a code snippet that is recommended by Aroma does not come from one single specific match in the code base. Aroma is trying to find fuzzy matches and then synthesize an approximate match based on those. It also does not require identifying common patterns ahead of time. It goes wherever the data takes it. The Aroma algorithm is based on parse trees or abstract syntax trees of the language which it is working on. So it's not specific to one programming language and can be used for many different languages. But most importantly, it's fast enough to use in real time, which means a programmer could use it in their regular programming flow. So how does Aroma work? Given a large code corpus, Aroma extracts the parse tree or the abstract syntax tree of every method in that corpus. And then from those parse trees, it extracts structural features. Aroma runs in a number of phases. The first phase is a quick but approximate search. It takes its input query snippet, the one that you want to find usages based on, and then it finds about 1,000 methods that have the most overlap with your input code snippet. To do that, Aroma extracts features from your input query and then intersects that with the features of all the methods in its corpus and ranks them according to which ones are the most similar. Once you have this fast but imprecise query give you, say, the top 1,000 matches, it then uses a more precise but slower pruning and re-ranking mechanism. And the goal of this phase is to get a more precise measure of how similar these recommendations are to the input query. And then finally, of all these matches that it has ranked, Aroma tries to cluster the similar recommendations together. Here's an example of what the abstract syntax tree would look like if you consider this code snippet. Its corresponding abstract syntax tree looks like this. You'll notice that variable names have been abstracted out because the specific names don't matter. We just want to see the patterns of how the variables are being used. I'd encourage you to read the full paper for the details of how exactly they extract features from the abstract syntax tree. But one detail I want to look at is how they compute the overlap between the input query and this massive corpus of code that the tool has indexed. Even though there are a large number of unique features that Aroma finds over its input corpus, each individual method only has about 63 features. I think that's a typo over here. They meant features. So these feature vectors are very sparse, and it turns out that you can do matrix multiplication over sparse matrices very, very fast. So even over a very large corpus that you're searching over, if you represent the features as a large but sparse matrix, you can multiply that matrix very, very quickly. In fact, they notice that it happens in under a second. Let's look at the last step, which is clustering. We want to cluster our results so that we don't present results that are all similar to each other. We want to cluster together the similar results and then present only one result from each cluster. Intersecting all the similar snippets within a cluster also helps create results that are much more targeted and specific. So how did this tool perform? For their evaluation, the authors indexed about 5,400 GitHub projects that were written in Java for the Android platform. And then as a test, they picked the 500 most popular Android questions on Stack Overflow. To construct their input queries, they took the first half of the code snippets in these Stack Overflow questions. They picked 64 randomly selected questions out of the top 500. And what they found was that in about 74% of the cases, one of the top 5 Aroma results matched the original code snippet. That is the answer, the top voted answer from Stack Overflow. But they also integrated this tool with an IDE and then used that to do a real developer study of the effectiveness of this tool. They gauged the usefulness of the tool by giving the developers a survey, and they asked the developers whether they found Aroma useful and whether the developers wanted Aroma to be available in more languages. And for each of these questions, they got largely positive answers. They asked the developers for more detailed feedback, and a lot of them pointed out that Aroma was indeed useful for discovering common usage patterns. It's also interesting to note that some developers started treating Aroma's results as documentation for the methods that they were trying to use. So that was a quick look at Aroma, which is a code recommendation tool that tries to find code snippets similar to the one you're writing. I hope you enjoyed that, and I will see you next time. Thank you very much.